come on.
What's wrong?
I get the Diet Coke and you gave me a Sprite.
Oh, I guess it means it's not functioning.
I'm glad my sadness is happy for you.
Let's go, guys. Math.
Functions!
It's all right, it's okay. This gives me an opportunity to talk to my students about functions. Let's go to the board.
All right, students, so now that we're at the board, we're going to talk about functions and whether or not something is a function. First, let's start with the definition. In mathematics, a function compares a set of inputs, x, to a set of outputs, y, and assigns to each element of x exactly one element of y. The set x is called the domain of the function, and the set y is called the range of the function. Now, I know what you're saying. You're like, seriously? That's the definition? That's crazy. But I have a simple definition for you. Any input of x of a set should result in only one output, or y. Much simpler, right? So let's look at an example with the vending machine. In order for a vending machine to work or function, you should be able to get the item that you select, and only that item. If the Skittles are item D10, and I would input D10 on the keypad, then the machine should give me or output the Skittles. Just like this. But what if you push D10 to get another bag of Skittles, but instead you got a Good and Plenty?
Bruh.
Nobody wants that. If you've ever had one of these things, they are terrible, unless you like black licorice. But we would say the machine is broken or not functioning because we said that each input produces only one output. That would not be a function. So let's look at some more of this. In math, you're generally going to see the data displayed in a few different ways. You could have inputs and outputs, domain and range, or simply x and y. All of these terms are basically the same and can be used interchangeably for our purposes. You may also see them displayed in different ways, like domain mapping, which looks like this. Here you have two sets, and they have an input going to an output. You could also have a table, which is x and y's, or domains and range, or inputs and outputs. You can also have an ordered pair, which is just points off of a graph, or simply a graph. We're going to show you how to deal with each of these today. Let's start with domain mapping. For domain mapping, you'll be giving a set of inputs and outputs. Domain and range, or x and y, can be used also. And again, it looks like this. You have two ovals here, or two sets, and you're going to have arrows that are going to connect the inputs to the outputs. Remember that each input must only give one output if it's going to be a function. So if the domain map is a function, each input would lead to only one output. If even one of the inputs leads to more than one output, it is not a function. So now let's look at some examples of domain mapping. For this one, we have an input of 1, 3, 5, and 7, and an output of 2, 4, 6, and 8. And you can see that each of these inputs goes to exactly one output. 1 goes to 4, the input of 3 goes to 2 on the output, the input 5 goes to the output 8, and the input 7 goes to the output of 6. So since each of these inputs produces one output, that is a function. On this set, we have inputs of the same numbers, 1, 3, 5, and 7, and outputs of 2, 4, 6, and 8. Except in this case, we need to look right here. This input of 1 has two outputs because 1 goes to 2 and to 4. That would be like hitting that machine trying to get your Skittles, and instead you're getting a Good and Plenty. We would say this is not a function. It's important to remember our rule about functions. Each input relates to exactly one output. But what if an output is connected to multiple inputs? Or what if more than one input is connected to the same output? What happens then? Well, if you look at this case, we have two inputs, 1 and 3, giving the same output of 2. Is that okay? Well, since the rule about functions holds true that each one gave exactly one output, this is a function. It's okay that same inputs give the same output. Let's return to the vending machine example to test this out. So here's our vending machine again, and we said earlier that input D10 would get us Skittles. Well, there's another input we can use to get Skittles, because even though this is D10, we can input E10 with the one right below it, and we would still get Skittles. This only becomes an issue when you enter the same input but get two different outputs. For example, if I pressed E10 again and I got the Good and Plenty instead. And again, nobody wants that. Now let's look at tables. This is a common way you're going to encounter functions. The table can use any of the terms we discussed: inputs, outputs, x, y, domain, range. For this example, it says inputs and outputs. We have x's and y's, or again, inputs and outputs. The same rule applies for functions. Each input x gives only one output y. So we look at this first example. We have inputs of 1, 2, 3, 4, and 5, and outputs of 6 for every single one. But since each input gives exactly one output, this is a function. This would be just like having 5 spots on the same vending machine that would give you the same candy. So each of those inputs would still give you the candy you want, and it would only give you the candy that you want. It's a function. On the second one, we have x's and y's. The x's are 3, 1, -2, and -3. And they would give you y's of 5, 1, -5, and -7. Since each x gives you exactly one y, this is definitely a function. Now let's look at the last example. At first glance, it does look like each input gives you one output, except for the fact that each of the inputs are 3, which means it's the same input giving you multiple outputs. So that is not a function. Now it's time to look at some ordered pairs. With ordered pairs, they're basically like points on a graph, where x is the first digit and y is the second digit. And they look like this. So if we look at the first set, which is the orange set, we have 5, 3, 2, 7, -2, 6, and 1, 5. Remember that the first digit is the x and the second digit is the y. So since each x or input gives us exactly one y or output, this is a function. If we look at the yellow set of ordered pairs, we have to notice something very important right off the bat. We have two x's that are the same, -1. And since these two numbers are the same, that means the same x is giving us two different y's, 5 and 6. Since one input cannot give us two outputs, this is not a function. Now let's look at the silver set. With the silver set, we see that all the y's are the same. But if you remember from our discussion on tables, the y's can be the same. So that's okay in this situation, because every x gives us exactly one y, which means that this is a function. When you look at the last set, we have 2, 3, 2, 7, 2, 6, and 2, 5. Now the problem here is that all of the x's are the same. So just like our last example in the tables, we can't have the same x giving us multiple y's. So this is not a function. Now it's time that we can look at some graphs. To determine that a graph is a function, there's an easy way to check it out. Remember that each input should have exactly one output. We can look at these graphs. Since we said that the input is an x value and the output is y, we can check the graphs by looking for multiple points on the y-axis that are at the same x value. That means we can use a vertical line to check for functions, since it would have infinite y values for the same x value. If the vertical line touches the graph more than once in any location, that means the graph has more than one y for that x value. Let's check these graphs. Since that line touched the graph twice in multiple places, that is not a function, because if it was a function, it would only touch one time. Let's check the second. Anywhere along that line, the vertical line would only touch it one time, which means that it is a function. For the last one, It might be tricky to see, but anywhere along that curve, the vertical line touches it only one time. So that is also a function. To determine that you have a function, every input must lead to only one output. For example, let's go back to our vending machine. Any input that you punch in should give you one output. However, if any input gives two outputs or more, that would not be considered a function. Again, for example, we put in our code. First time we get Skittles, we put it in again, we get Good and Plenty. Nobody wants that to happen. We would say that that is not a function. There's so much more to learn about functions, but that will be covered in a future video. And now it's question time. It's time to look at these functions and find out if they even are a function. Let's do these together. First, we have a domain map, input and output. Since each input gives exactly one output, it's a function. Next, let's look at a table. We have inputs and outputs. But if you notice, we have a couple of the same inputs giving us different outputs. We have 2, 3 inputs giving us -5 and -1. We also have two inputs giving -4 and -2. So since we have multiple inputs that are the same giving us different outputs, that makes this not a function. Now we can look at the ordered pairs. Now if you look at the ordered pairs, you obviously noticed it, there are 2 of the same input. But if you look at it, they're giving us the same output. So in a way, it's one input giving us one output. So this is actually okay, and it will be a function. Last one, we have a graph. So let's use our vertical line test, and let's see just how well this holds up. Yep, you guessed it. Since it touches the graph twice on the vertical line, that means there's 2 y's for that one x value, so this is not a function. Alright, now it's your turn. Try these on your own. I'll give you some music to work to. Feel free to pause the video in case I go too fast for you. Good luck.
Alright students, so that's all you need to know about functions for now. If this video has been helpful for you, hit the like button, subscribe to the channel, and leave a comment down below so that I know how I can help you further. So, until next time, see you later.
It's